California drowns, not might drown, does on a schedule, and there's a physical record of it buried in the seafloor. Scientists pulling sediment cores from the Santa Barbara Basin and the Sacramento Valley have counted the layers, and every one of them is the receipt for a megaflood. The years 212, 440, 603, 1029, around 1300, then 1418, 1605, 1750, 1810, and the last one in 1861. That is an average of one every 100 to 200 years. The last one was 164 years ago. It rained for 43 straight days. More than 10 feet of water fell. The Central Valley became an inland sea 300 miles long, and the state capital went under 10 feet of water on the day a new governor was sworn in. California went bankrupt and could not pay its own government for a year and a half. And 4 of the floods in that list, 440, 1418, 1605, and 1750, were bigger than the one that did all of that. The United States Geological Survey has now modeled what a repeat costs on the modern state, and the number is between $725 billion and $1 trillion, with a quarter of every building in California underwater. Well, why 1605 was the monster of them all, and the one thing about snow that has made the next one worse than any that came before is where this goes. But first, what actually falls out of the sky to do this? The machine behind all of it is called an atmospheric river. It is exactly what the name says. A long, narrow corridor of concentrated water vapor flowing through the sky, carrying moisture up out of the tropics and hurling it at the coast. They are enormous. A strong one moves more water through the air than the Mississippi carries on the ground. California is not a victim of these storms. California is built on them. A handful of atmospheric rivers each winter deliver a very large share of the entire state's annual water supply. They fill the reservoirs, load the Sierra Nevada with snowpack, and keep the farms running. The state's whole existence depends on them arriving. The catastrophe is what happens when they do not stop. ARkStorm is not one storm. It is a conveyor belt of them, striking the same coastline one after another for weeks, so that the ground never drains, the rivers never fall, and the reservoirs run out of room to absorb anything. Every storm after that point lands on a state that is already full. That is the scenario the USGS modeled, and it is worth knowing how they built it, because it was not invented. In 2010, a team led by Lucy Jones, then chief scientist of the USGS Multi-Hazards Demonstration Project, constructed the storm by stitching together 2 real events that had genuinely hit California. A Southern California storm from January 1969, and a Northern California storm from February 1986. They took real weather that really happened and ran it back to back. The name they gave the result, ARkStorm, stands for Atmospheric River 1000, marking it as roughly a 1 in 1,000 year class of event. What the model produced was the drowning of the most productive farmland in the United States. Water pools in the Central Valley faster than it can escape through the Sacramento-San Joaquin Delta, the single narrow outlet where the valley's rivers reach San Francisco Bay. The valley fills, 300 miles long, over 20 miles wide, a sheet of water sitting where the fruit, nuts, and vegetables for much of the country are grown. Roughly a quarter of California's buildings take on water. More than 1.5 million people are displaced, and the price tag, somewhere between $725 billion and $1 trillion, makes it substantially more expensive than the great earthquake everyone actually worries about, which is why the USGS gave it the nickname that stuck, California's other big one. The reason the valley fills rather than drains comes down to one bottleneck. Nearly every river in Central California, the Sacramento coming down from the north, the San Joaquin coming up from the south, and everything draining off the Sierra Nevada in between, has to leave through the same place, the Sacramento-San Joaquin Delta, a maze of channels and islands where the 2 river systems meet before reaching San Francisco Bay. It is the only door out. Everything upstream of it is protected by an enormous network of levees, many built generations ago on soft ground, holding back water that in places already sits higher than the farmland beside it. A levee system is only ever as strong as its weakest section, and it is designed against a storm of a particular size. ARkStorm is deliberately bigger than that design. Now, the part that turns this from a modeling exercise into something with teeth, because this has already happened, and there are records of it. In the winter of 1861 into 1862, it rained across Central California almost without stopping for 43 consecutive days. More than 10 feet of rain fell, along with heavy snow in the mountains. The Central Valley filled and became an inland sea, 300 miles long and about 20 miles wide, which is to say almost exactly the shape the modern computer model reproduces a century and a half later. About a quarter of the state's landmass went underwater. On the 10th of January 1862, the day Leland Stanford was to be inaugurated as California's new governor, the floodwater broke through the levees around Sacramento and buried the city under 10 feet of brown, debris-filled water. He took office in a drowned capital. Government business had to shift to San Francisco because the seat of the state was underwater. The damage came to roughly $100 million in 1861 money, about $3 billion in today's terms, in a state with a tiny fraction of its current population and almost none of its current infrastructure. And it broke the government's finances outright. The governor, the state legislature, and state employees went unpaid for a year and a half. Enormous numbers of cattle drowned, gutting the ranching economy that California had been running on. That is the event. Not a projection, not a model. A documented catastrophe that emptied the state treasury and drowned the capital, inside the lifetime of people whose grandchildren saw cars. And the version that matters is not the one that happened then, but the one that would happen now on the same ground. In 1862, the Central Valley was ranch land and scattered towns with a state population in the hundreds of thousands. The identical weather today would fall on Sacramento, Stockton, Fresno, and Bakersfield, on interstate highways, rail lines and aqueducts, on the aqueduct system that carries water south to Los Angeles, and on farmland that supplies a very large share of the fruit, nuts, and vegetables eaten across the entire United States. The rain would be the same. What sits underneath it has multiplied 100-fold. That is the whole reason a 19th century flood produces a 21st century trillion-dollar figure. And then, in 2022, the question was reopened with modern climate science. Daniel Swain, a climate scientist at UCLA, and his co-author Xingying Huang, working with UCLA and the National Center for Atmospheric Research, published new work in the journal Science Advances. They rebuilt the megastorm in two versions, one in a historical climate, one in a future one, and compared them. Their central finding was blunt, and it is the reason this topic came back into the news. Climate change has already made an event capable of producing catastrophic flooding in California roughly twice as likely as it used to be. But the mechanism underneath that number is the part that deserves the most attention. And it is not about rainfall totals at all. It is about snow. Here is why that matters more than anything else in this story. When a winter storm hits the Sierra Nevada in cold conditions, most of the water arrives as snow. Snow is storage. It sits on the mountain for months and releases slowly through spring, which is precisely how California's reservoirs and irrigation systems were designed to be fed. Warm the atmosphere, and the same storm delivers the same water as rain instead. Rain does not wait. It runs off immediately, straight down the mountain into rivers and into the valley all at once during the storm. The study projects that end-of-century storms would generate 200 to 400% more runoff in the Sierra Nevada, not because vastly more water falls, but because far more of it arrives as rain rather than snow. The mountains stop acting as a reservoir and start acting as a funnel. That is the difference between a wet winter and a flood that empties a state treasury. There is also a cruel irony sitting inside California's water problem, and the two halves of it are happening at the same time. The state has spent most of the past 2 decades in drought, watching its reservoirs fall and arguing over shrinking supplies. Nothing about ARkStorm contradicts that. A hotter atmosphere holds more water vapor, which makes the wet extremes wetter, while the same warming makes the dry stretches drier and the snowpack less reliable. The forecast is not flood instead of drought. It is both swinging harder and faster between them, in a state whose dams, canals, and levees were all designed around a steadier middle that is disappearing. Reservoirs kept low for drought security have room to absorb a flood. Reservoirs kept full for water supply do not. Which mistake to make is a decision somebody has to take in advance, with no way of knowing which year is coming. It is also worth saying plainly what the recurrence estimates do and do not mean. The updated work puts an event capable of catastrophic flooding at roughly once every 25 to 50 years, which is a very different figure from the 1 in 1,000 framing in the original name, because the modern estimates cover a broader class of severe events, not only the most extreme version. What every version agrees on is direction. The probability is going up, not down. There's one more reason this scenario is treated as a planning emergency rather than a curiosity, and it is about insurance. Earthquake and flood damage in the United States are largely handled outside ordinary homeowner policies. Standard cover excludes flooding, and federal flood insurance is bought separately, mostly by people who have been told they are in a designated flood zone. An ARkStorm scale event would put water into enormous areas that are not designated as high risk at all, because the maps are drawn against ordinary storms rather than a 45-day siege. That means a very large share of the loss would land directly on households and on public budgets rather than on insurers. The trillion-dollar figure is not just the cost of the damage. It is the cost of damage that mostly nobody has bought protection against. Nobody can say which winter it arrives in. That is not reassurance. It is the problem. The sediment record gives an average of 1 every 100 to 200 years, and the last one was 164 years ago, which places the present firmly inside the window rather than safely outside it. The record does not tell anyone the date. It only says that the gap has never stayed open forever, and the arithmetic underneath is worse than the average suggests. 4 of the floods in that seafloor record were larger than 1862. The flood that turned the valley into a sea and bankrupted the state was not the worst one. It was a middling one. The largest, in 1605, left a silt layer twice as thick as any other, meaning that storm was at least half again as powerful as the one modern California considers its nightmare. Whatever California is preparing for, the ground says it has done bigger. So the honest summary is not that a model predicts a flood. It is that the seafloor holds 10 receipts for this happening already. That the average gap between them is a century to 2 centuries. That the last one was 164 years ago. That 4 of them were bigger than the one which bankrupted the state. And that the mountains, which used to hold the water back, are now increasingly handing it straight down. California has spent a century preparing for the ground to move. The other big one does not shake anything. It just does not stop raining. Subscribe for the real numbers on the next one, verified and in full.